Okay, guys, so this is the second part of Lab 3, Polynomial Identities. It's going to be a quick one, and we purposely did this because it's the same week as the test. We didn't want to fry your brain. So I'm going to call this one 3B, and instead of doing pages 5 through 7 odds, you're going to finish the evens. Okay, whatever I don't cover in the notes, you're going to cover for homework. So number 2 is going to be homework. Number 4, I'm going to do with you just because a lot of people mess this up. Basically, we have subtraction and exponents here, so we have to do the exponent piece first, and then we're going to have to subtract that whole product. So the y plus 3, this first polynomial, this first binomial, doesn't even have to be in parentheses since there's nothing outside to distribute. There's nothing to multiply or nothing to multiply on either side. So the parentheses are not necessary. And I'm going to subtract the product, okay? When I square this binomial, I'm going to get a trinomial. Okay, so you could write it twice, or maybe you know the shortcut by now. Okay, if you're multiplying y minus 2 times y minus 2, we're going to double distribute, and we're going to get y squared. Since this negative 2y and this negative 2y will match, I'm just going to double that to get negative 4y, and then negative 2 times negative 2 is a positive 4. All right, so I'm subtracting this whole trinomial so that negative is really distributed. You could think that subtracting, since we're subtracting this, so subtraction is the same thing as adding the opposite. So basically what we can do is subtracting is the same thing as adding the opposite of this. So the opposite of y squared is negative y squared. Negative 4y would change to positive 4y, and a positive 4 would change into a negative 4. Okay, so you can think of adding the opposite, or you can just distribute the negative to each, and it'll change each of their signs. Okay, so now we're just left to simplify this, which means combining like terms. So we start with the highest exponent. This is a second degree expression, so a negative y squared. And then we have this y, which is a 1y plus 4y, to give me a positive 5y. Okay, I just put those y terms together. And I'm going to add the 3 and the negative 4 to get minus 1. So this would be my final answer for that one. Okay, 6 is going to be homework. I modeled number 5 in the previous notes. Okay, 8 is going to be homework. And 10 will be homework. Okay, just practice with polynomial operations. Okay, so when we get to page 6, we're really talking about the identities again. And remember, an identity is something that's always true. You should have finished number 1, which is an odd, last time. All right, so for exercise 2, I'm going to actually have you guys prove, oops, let me move this. I'm going to have you prove the identity, but I'm going to help you use it to evaluate 35 squared. All right, so you still have to prove the identity, and you can do that by expanding or manipulating the left side. Okay, so you're going to change this side, and you should end up with 2 identical sides. But I'm going to do this part with you. Use it to evaluate 35 squared. So basically, if I want to do 35 squared without using a calculator, I can turn 35 into the sum of 2 numbers. So I could pick any 2 numbers. I could pick 20 plus 15. I could pick 30 plus 5. I could pick 10 plus 25. So I'm going to choose to use 30 plus 5 here. Okay, so therefore, I'm going to say A. Okay, if you compare it to my identity, my first number here is, they call it A. And the second number is, in this case, going to be 5. All right, so basically what they're saying the identity is, instead of A plus B squared equals A squared plus 2 times AB plus B squared, I can plug in 30 for A and 5 for B, and this will allow me to do 35 squared in my head. Okay, this is the same as 35 squared. So I'm going to take my A value and square it. So I'm going to do 30 squared plus 2 times my A, which is 30, times my B, which is 5, and then I have to add my b, which in this case is 5 squared. So 30 squared is kind of like 3 squared, but I'm going to add a couple zeros. So 30 times 30 is be 900. Okay. 2 times 30 times 5. Well, I could do 2 times 5 is 10, and then 10 times 30 would be 300. And then 5 squared is 25. And if I add all of these together, I get 1225. So it just shows that there is a way to do 35 squared using mental math if you know the identities. So the identities could help us do traditionally non-mental math, and we can turn it into mental math by using an identity. All right, so you're still going to prove the identity. You're going to do the first part of exercise 2 for homework. All right, so I'm just going to circle it, reminding you that it's finished for homework. Okay, exercise 3 was part of lab 3A. Okay, exercise 4 is going to be homework. Again, you're going to be taking a binomial to the third power. And it says prove this identity. When it says prove the identity, like I said, you should end up with 2 identical sides. They're telling you this is an identity. Okay, so they should come out as 2 identical sides. So don't get to the end and say, oh, this is not identity because this doesn't match. If you end up with that situation, then you're doing something wrong. All right, I'm also going to talk about this identity. I'm going to go back to page 5 because there was an example like this on your homework. Okay, so I'm going to talk about number 9, any binomial cubed. All right, so they write it as a plus b cubed, which can represent any binomial cubed, is equal to a cubed plus 3a squared b. Okay, in this case, we're going to put the squared with the a, plus 3a, now the b's turn to be squared, plus b cubed. Okay, so this is the identity if you want to memorize it, and it'll save you some work. All right, so I'm just going to verify that before I start. Okay, so it's, like I said, a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, that's the identity. They're telling me it's definitely an identity. So now next time I see a binomial cubed, if I memorize this identity, I can easily do this. All right, in this case, my a, instead of a, I'm going to use a y, and my b value is -2. Okay, instead of a and b, we're using y and -2. All right, so now I can say y minus 2 cubed is the same thing as, instead of a, I'm going to substitute a y, so it's y cubed plus 3 times y squared times b, which is -2. Okay, I'm just substituting, plus, now I'm on this guy, 3 times my a, which is now y, times a -2 squared plus -2 cubed. Oh, yeah. All right, so now if I just simplify this or reduce it, I get y cubed. Okay, this whole product would be minus 6y squared. Okay, this product, I would do -2 squared, which is 4. And then 3y times 4, I'd get plus 12y. And then -2 cubed is -2 times -2, which is 4, times a -2, which is -8. So hopefully this is the answer that you got when you cubed y minus 2 in lab 3A. And that just shows you how you could use the identity to your advantage. All right, so you still have to finish exercise 4. That's part of your homework. 1 should be finished. 2 is homework. This should be an easy question. You're just looking for the equation that's always true, because an identity is an equation that's always true. And then we have number 4, this last number 4. So it tells us we should be well aware of this. This is the difference of 2 perfect squares, and if we put it in factored form, it's conjugate pairs. So we should be super familiar with this identity, okay? But it tells us instead of the difference of 2 perfect squares, there's also an identity for perfect cubes, okay? So you're going to do part A, where you just do the math, and you keep going until the 2 sides of the equation are identical, okay? And it tells you basically to just expand the product on the right-hand side. So what that means is you're just going to distribute on the right-hand side and combine like terms, and you should get the left side. But I'm going to do part B with you. It says use the identity to find the value of 10 cubed minus 9 cubed without the use of our calculator. So again, I'm just going to copy down the x cubed minus y cubed equals x minus y times x squared plus xy plus y squared. And I am just going to plug in 10 for x and 9 for y. All right, so I'm going to get 10 cubed minus 9 cubed, right? I wouldn't want to do this in my head, okay? But I can do this side in my head. I have 10 minus 9, okay? And then I have 10 squared plus 10 times 9 plus 9 squared. So if I just simplify this, okay, 10 minus 9 is 1, and then I have 10 squared is 100, plus 10 times 9 is 90, plus 9 squared is 81. So basically I just have to add these to get my value of 10 cubed minus 9 cubed. And I have 190 plus 81, which is 271. Okay, so 10 cubed minus 9 cubed is 271. It says to verify with our calculator. We can do that as well. Okay, so I did verify in the calculator, everything checks out. All right, so your job is to finish all the evens and to copy the notes. All right, have fun. Bye.